Hi, this is Zohair Chaudhary. Today we'll talk about health impacts from climate change. So before we can understand the health impacts from climate change, it is important to understand the various temperature scenarios that are being projected. This graph shows the average mean global temperature for about 1000 years and the projected global mean temperature going into the future up to 2100. And this is based on the various IPCC scenarios. So from a low end, global temperature could increase as much as 2 degrees, or from a high end could increase as much as 5 to 6 degrees. And these are the specific projection from IPCC. So using those projected temperature increase from the mean, we can see that for food, water, ecosystem, or extreme weather events, as well as possible climatic changes, what could be the various impact and the degree of those impacts as the temperature increases from the mean to a set number of temperature. Currently, we have already experienced a 1 degree Celsius increase of temperature, and we are already seeing falling crop yields in many parts of the globe, especially in developing countries. But at the same time, we're also seeing rising yields in some of the high latitude regions of the globe, especially in Canada and Siberia, because their growing season has been increasing currently. For water, we are seeing water shortages in some areas, flooding in the other areas, and in many areas of the globe we are seeing glaciers that are disappearing and sea levels slowly rising. For the ecosystem, at this 1 degree Celsius increase that we have already experienced, some of the coral reefs, actually many of the coral reefs, are getting severely damaged from temperature rise and ocean acidity. And with all of this, we are seeing rising extreme weather events that are leading to the beginning phases of some of this rising intensity of storm, forest fire, and droughts. As the temperature increases, we'll see that each of these things that we just talked about, it just becomes more and more severe. So the further we go in here, the more severe it is. The further we are in here, it's at the beginning phases of that specific scenario. So the more red it is, the redder it is, the more severe the consequence is, and the yellow is the beginning phase of that scenario. Something very important that needs to be noticed in this slide is what would happen at around 1.5 degree to 2 to 2.5 degree. This zone in here is a zone of extreme concern. In fact, at this temperature, we are right at the beginning phases of risk of abrupt and major irreversible changes in the climate system. That's the beginning phases. As the temperature increases, these dangerous feedbacks and large-scale shifts would start increasing and would start magnifying. So let's pause and try to understand what are these dangerous feedbacks and large-scale shifts in the climate system. For example, if Earth's temperature keeps on increasing, we'll start experiencing severe melt of glaciers, and in some cases in ice sheets over Antarctica and Greenland, we'll see the ice sheets to start destabilizing because of the melt, and the water that is melts will start destabilizing the ice sheets and may crack and fall in big chunks into the ocean. So these big chunks falling into the ocean can lead to massive flooding as well as excessive sea level rise suddenly. At the same time, at this temperature, at this increase of temperature, permafrost, which are located in Siberia and Alaska as well as northern Canada, may start melting very, very fast. And permafrost is essentially permanently frozen ground in this northern hemisphere, which would lead to some of the trapped methane gases in this under this permafrost layer, which would release the methane gas, which is a greenhouse gas, and in turn increase the global temperature much faster than it had been without the permafrost melting. So, and these are just two possible examples, and there are many more, such as ocean current shutting down and many other feedback mechanisms that are interrelated. At this temperature, we start seeing some dangerous feedbacks. What is important to know that once we start going towards these dangerous feedbacks, there's no going back. What that means, once the ice sheet starts cracking and falling into the ocean, those ice would not immediately come back up. It would take a long time before we start seeing a glaciation all over again. At the same time, once the permafrost starts melting and the methane gets released, that methane is not going to go back into the permafrost again. So those are irreversible damage to the climate. This chart shows how climate change relates to regional level of climatic changes, which in turn leads to some intermediate factor which could be related to human exposure, and at the end, the adverse health effects that are associated with that type of climatic exposure. So let's follow along. As climate changes around the globe because of temperature increases, precipitation changes, regionally the effect will be different. In some areas we'll see flooding, in other areas we may see droughts or forest fires or other things. In the coastal area, this will translate to slow and steady sea level rise, which in turn will lead to coastal flooding and thus increase of salinity in the coastal aquifer, which in turn can lead to people getting displaced because of sea level rise and drowning issues, as well as injury issue because of the rising level of the ocean and tide. On this other hand, as temperature changes and increases, we can start seeing directly heat-related illnesses and death, as well as extreme weather-related health effects. And on the intermediate level, some of these changes, such as temperature increase, can lead to air pollution concentration increases, as well as pollen production increases, as well as changes in microbial contamination, which in turn can lead to air pollution-related health effects, allergic diseases increases, as well as changes in vector-borne transmission and their ecology. In here, we have already talked about how temperature and precipitation pattern changes will cause crop yields to be impacted, especially in developing countries, which in turn will lead to malnutrition in those already malnourished places of the globe. So this is a quick summary how climate change will lead to the rising temperatures, more extreme weather pattern, rising sea levels, as well as increases of CO2 levels, which in turn will lead to air pollution related exposure increases, changes in vector-borne ecology, increases in allergy, as well as changes in water quality and water and food supply impacts, and extreme extreme heat and severe weather pattern, which in turn each of them will lead to the adverse health effects. For example, from air pollution, we'll start seeing increases in asthma and cardiovascular diseases. With changes in vector ecology, some of the vector-borne diseases will start impacting. So, etc., etc. You can follow along each of the spike and see how exposure to this climate-related effect can lead to the health effects associated with it. And as it lies, developing countries are the ones that are the most vulnerable. Why? Because developing countries already are struggling with many problems, and they are already very tight with respect to financial and institutional and technological capacity. And as climate changes, there will be increased pressure on their economy, on their capacity to be able to respond properly to the changes needed in order to fight changes in climate. Okay, so let's quickly check some concepts. So true and false. Since pre-industrial time, global temperature has risen by about 1 degree Celsius or 1.5 degree Fahrenheit. True or false? true. So this specific concept check is coming from right here. In fact, from pre-industrial time, we have risen about 1 degree Celsius, and we can also see it in here that we are about 1 degree Celsius increase from pre-industrial time. Another concept check: if global temperature were to rise by 2 or more degrees Celsius since pre-industrial time, dangerous and irreversible climate feedback may happen. Yes, true. And this is coming from this slide in here, as we mentioned that as from 1.5 to 2.5, right around here, we'll start seeing some dangerous feedbacks of the climate system. Okay, thank you. That's all.